Dear students, this is Praveen KM, and in today's episode we will discuss some of the very important concepts and questions from the chapter Ray Optics and Optical Instruments. Students, it is a very important chapter carrying on an average of some 3 questions in competitive exams. So, kindly pay attention and list out all the formula and shortcut that we discuss. Let us go to synopsis part. In my synopsis part, I do not want to discuss all the formulae that are there in the chapter. Instead, I have listed out very useful formulae. Okay, let us start with the plane mirrors. The magnification produced by a plane mirror is +1. It is plus because the nature of the image is virtual, and it is 1 because the size of the image is same as that of the object. The important idea about plane mirror is the number of images. When 2 plane mirrors are inclined at an angle theta, then the number of images depends on a quantity 360 by theta. If 360 by theta is even, then the number of images is 360 by theta minus 1. That is it, irrespective of the position of the object. If 360 by theta is odd, then there are 2 cases. In the first case, if you place the object on the bisector, then the number of images is 360 by theta minus 1. If you place the object anywhere else other than the bisector, then the number of images is 360 by theta itself. Moving on to spherical mirrors, 2 important types of spherical mirrors, convex and concave. Okay, the nature of the images are very important here. Concave mirror produces real image in most of the cases. Real is always inverted, remember, but there is one exception, that is when the object is kept within focus, then the nature of the image is virtual, erect and on the other side of the mirror. Coming to convex mirror always produces a virtual image which is diminished irrespective of the position of the object. Okay. Then mirror formula 1 over f is equal to 1 over u plus 1 over v with proper sign conventions. And moving on to magnification, you are familiar with m is equal to minus v by u, but there are 2 more important formulae for magnification in terms of focal lengths which are also important. M is equal to f minus v by f in terms of image distance, and m is equal to f by f minus u in terms of object distance. And as you all know, by the ideas of magnification, M positive means virtual image, M negative means real image, and also if M is greater than 1, image is enlarged, if M is less than 1, image is diminished. Next important concept is total internal reflection. As you all know, when a ray of light travels from optically denser to rarer medium, if the angle of incidence is greater than critical angle, then TIR takes place, and critical angle is connected to refractive index, which is given by the formula n is equal to 1 over sin IC. And based on this formula n is equal to 1 over sin IC, you can expect a problem, that is when inside a denser medium, when there is an object kept, it sends out light forming a cone inside that denser medium, which produces a circular patch on the top surface of that denser medium, let us say water, and you will be asked to find out the radius or the area of that circular patch. So, radius of that circular patch can be calculated using the formula R is equal to H tan IC, where IC is the critical angle and H is the height up to which that liquid medium is filled. And when critical angle is not given, when refractive index is given, you can directly make use of another formula, R is equal to H by square root of n square minus 1. Then refraction through spherical surfaces, there is only one formula which is very important for all the cases of refraction through spherical surface. It is given by n2 by v minus n1 by u is equal to n2 minus n1 by r. So, students have to be very careful while using this formula along with sign conventions. And let us move on to lenses, 2 important types of lenses, convex and concave. And regarding the nature of the images, convex produces real image in most of the cases. There is one exception, that is when the object is kept within focus, it produces a virtual image which is enlarged. Then coming to concave lens, concave lens always produces virtual image irrespective of the position of the object, and this image is always diminished and it is between the optic center and focus. It is always virtual irrespective of the position of the object. The lens formula is 1 over f is equal to 1 over v minus 1 over u along with sign conventions. Then magnification is m is equal to v by u. There was minus sign in mirror but not in lens, and magnification can also be given again in terms of focal length of lenses, that is m is equal to f minus v by f and m is equal to f by f plus u. Students, please do compare these three magnification formulae with those you have studied in case of mirrors. You can avoid those confusions only when you compare these two formulae. And as usual, positive magnification for virtual, negative for real, so and so forth, as usual as it was in case of mirror. Moving further, lens maker's formula is given by 1 by f is equal to n minus 1 into 1 over r1 minus 1 over r2 with proper sign convention, and it is when the lens is surrounded by air. And this reciprocal of focal length is nothing but the power of the lens, and it is positive for convex and negative for concave. And when two or more lenses are kept in contact coaxially, then the effective focal length is given by 1 over f is equal to 1 over f1 plus 1 over f2 plus 1 over f3, so on. Then moving on to prism formula, when the prism is kept in minimum deviation position, then refractive index of the prism n is given by sine of a plus d by 2 divided by sine a by 2, where d is the angle of minimum deviation. And otherwise, when the prism is not set in minimum deviation position, any other deviation can be calculated using the formula delta is equal to I plus E minus A, where E is angle of emergence and A is angle of the prism. A is given by R1 plus R2. Now let's move on to eye defects and their remedies. Myopia or short-sightedness can be corrected by using concave lens of suitable power, and hypermetropia or far-sightedness can be corrected using convex lens. Astigmatism, where the person with this defect cannot focus on both horizontal and vertical lines simultaneously, this can be corrected by using cylindrical lenses. And we will have to remember the magnifying powers of optical instruments also. Moving on to simple microscope, its magnifying power is given by m is equal to 1 plus d by f, where that d is the least distance of distinct vision. And for compound microscope, you will have to remember a couple of formulae, that is m is equal to MO into ME, where MO can be written as VO by UO, ME is 1 plus D by FE. The same formula can also be written as m is equal to minus L by FO into 1 plus D by FE, where the symbols have their usual meaning. Here the negative sign indicates that the image is inverted. Now in telescope, the magnifying power is given by beta by alpha, which is also same as FO by FE, and the length of the tube is FO plus FE. You need to also study and remember the meaning of these symbols. With these basics and concepts, let's move on to some of the questions. The first question is like this: a car is fitted with a convex mirror of focal length 20 centimeter. A second car 2.8 meter behind the first car is overtaking at a relative speed of 15 meter per second. The speed of the image of the second car as seen by the mirror of the first is options 1 by 10 meter per second, 1 by 15 meter per second, 10 meter per second and 15 meter per second. Dear students, it's a problem on convex mirror, and what is the object? The object is an approaching car, and what are we supposed to find out? They have given you the focal length of the mirror, the distance of the object, that is object distance is given, focal length is given. What can we calculate? Image distance can be calculated, but the question is not that one. They have asked you to calculate the speed of the image. and for which they have given you speed of the object. This is not the usual kind of problem that we usually solve. Here speeds have to be defined. Do we know how to define speed of an object, speed of an image? If u is the position of the object or object distance, then the time rate of change of object distance is object speed. That is, if u is object distance, then du by dt is speed of the object. Similarly, dv by dt is speed of the image. So for this problem, we need to find out dv by dt using du by dt. But how do we get the expression for dv by dt? Take mirror formula and differentiate with respect to time. You will get an expression for dv by dt. Let me take out the mirror formula first, which is 1 by u plus 1 by v is equal to 1 by f. Just differentiate with respect to time. Minus 1 over u square into du by dt minus 1 by v square into dv by dt is equal to 0 since focal length is constant. Rearrange the terms. I want dv by dt, let me write it straight away. So dv by dt is equal to minus of v square by u square times du by dt. Here what are given? Speed of the object 15 meter per second is nothing but your du by dt, and u, that is the object distance, is 2.8 meter. We will have to write it in centimeter. Then what about this v? Focal length is given, object distance is given, find out v using mirror formula. Let me write the diagram. This is convex mirror, and here is the object which is approaching. It is at certain distance 2.8 meter from the mirror, and it is moving towards the mirror. Now 1 by f is equal to 1 by v plus 1 by u, and I want the image position, that is 1 over v is equal to 1 by f minus 1 by u. This is 1 by 20 positive minus 1 over u. It is in the opposite direction to the incident light, therefore u should be taken to be negative. Let me take it in centimeter since focal length is in centimeter. So this is 1 over minus 280. So LCM is 280, 1 over v is equal to, this is 14 plus 1 is 15. So v is equal to 280 by 15, it is centimeter. Now substitute for v here, u is known to be 280 centimeter, du by dt is 15 meter per second, that gives you du by dt. That is the end of the problem. So let me simplify this. Negative sign indicates the direction of velocity. If you want speed, you can ignore that negative sign, that is not a big deal. So this is v by u whole square, v is 280 by 15 divided by 280 whole square. I hope you understood this, into du by dt is 15. Look at this, gets cancelled, and you are left with 1 over 15 whole square into 15. It is just 15. Therefore, dv by dt is 1 by 15 whole square into 15. 1 15 gets cancelled, the other 15 remains in the denominator. It is 1 by 15 in meter per second, because this in centimeter, this also is in centimeter. Both u and v are in the same units, they get cancelled. You are left with the unit of speed of object, that is 15 meter per second. Therefore, image speed is also 15 meter per second, 1 over 15 meter per second. I think option B is the correct answer.